Okay, so this is number 30 in your book, and so I went ahead and just took a picture of this, and this is our figure, and we definitely have some triangles in there, and we've been working a lot with triangles in section 10.2. So the goal is, it says find the area of the shaded region in this problem. So the shaded region, right, is the blue guy. So we want to find the area of this guy, right? Say we're putting carpet, you know, in this shape, right, in a very modern home. So again, how do we calculate, you know, the square inches in order to find the area of this figure? And again, we have, right, we have this triangle here, and we also have this triangle here. So hopefully, and again, they're, you know, we have our metrics here, 16 inches, right, the height of this triangle is 6 inches, and then the height of this triangle is 9 inches. And of course, we have our 90-degree angle there. So hopefully you agree with me that the area of this shaded region, so maybe let's get a color it's similar to this, so I don't know, maybe this blue. So I want to find the area of this shape, right? This the area of this guy. So what's the area? Well, let's construct it knowing again what we've learned about triangles and the area of triangles. So hopefully again you can agree that this is going to be the area of, I'm just going to call it big triangle, and I'm going to subtract it, right? If we find this whole area and I subtract it by the smaller triangle, right, I get this left. So I'm going to get do minus a, maybe small, right? Hopefully kind of pictorially you can see, right? I'm going to find the area of the big triangle, and then I'm going to subtract. So let's see, that's my same triangle, and I want to subtract this guy, right? Because then this will be left over, this figure. Okay, so it's area of big minus area of small. So let me just move this over here. So the area of the big triangle, well, we know that's just half base times height. So what's the base of the big triangle? Okay, that's 16 inches. The height of the larger triangle, well, that's 9 plus 6, so that's 15 inches. And of course we're cutting that in half, and we'll calculate that in a bit. But let's go ahead and find the a small. So again, base height and cut it in half. So the base of the small triangle is the same, right? It's still 16 inches. So 16 inches. And what's the height? Well, the height is only 6 inches. And of course we're cutting it in half, right? That's what our formula says. So again, I'm just punching in this in the calculator. So 16 times 15 is 240. All right, and if we cut that in half, we get 100. Let me get my white here. 120, and it's inches times inches, so we have 120 square inches, right? So you have 120 little 1 by 1 inch squares that cover, right, the whole rectangle. Okay, so then we have, right, 16 times 6, so I'm just punching this in the calculator. I get 96, and then I cut that in half, and then I get 48, again, squared inches. And then I'm going to add these guys, right, because I want the, well, actually, no, I'm not going to add them. I'm going to subtract these guys because I want what's left over, so I'm going to subtract these. And so, whoops, so this guy, right, this is what we want to calculate, is going to be, right, 120 minus 48. And just punching that in, right, minus 48 gives us 72 square inches. So that is the area, right, of that shaded region. And again, hopefully that makes sense, the subtraction idea. You're obviously going to have similar problems on your ICA. Notice this was an area problem. You can also find the perimeter And I think there was one example by the author. She did it with a triangle. All right, but when you find area, right, you're finding the inside of an object. So in this case, where you're finding that shaded area, but you can also find the perimeter. I mean, this guy, the perimeter would be, if you're finding the perimeter, let's say, of this big triangle, right, it would be 16 plus whatever this side is plus whatever this side is. But in this case, they didn't actually give us these sides, and we don't know if it's an equilateral triangle, so I mean, we don't work that out. But again, similar figures. Anything that says perimeter, right, you're going to add, it's the kind of the outer boundary. Circumference is just another word for perimeter, but we use circumference for a circle. So that is pretty much it. Hopefully, again, that makes sense.